Hello everyone. So we have a good question from the chapter of Newton's law of motion. So I'll quickly go through the question, and it says that a train of mass pi kg is moving on a circular track of radius 5 meters, and the speed with which it is moving is also constant. It is equal to 1.27 meters per second, and the length of the train is half the perimeter of the track. And after all this information has been given, and we have to find the linear momentum of the train. Okay, so I've drawn a figure for you. It's pretty simple. This green color thing here is the train. Okay, now if we for finding the linear momentum, if we directly apply p equal to mv, we won't get an answer, because the train is moving, and since momentum, this quantity is a vector, for every single point the velocity vector has got a different direction. Okay, the vector has got a different direction, so quite naturally the momentum vector also will have a different direction. Okay, so we have to find the with the help of integration we have to find out the linear momentum. So as you can see, I've taken a small mass dm, and this purple colored thing is the direction of the velocity. This is the direction of the velocity, okay, which will be tangential to the path, right? And I've taken a few angles here. This angle is phi. This angle is also phi because of alternate angle, that theorem. And this angle is also phi. Why? Because this angle right here, this angle is 90 degree. Okay, this entire angle is 90 degree. So yeah, the calculations are not very difficult. You can find that out why the angle is phi. Okay, so now we have to find momentum in two directions, that is in x-axis and the y-axis. Okay, so first let me find out the momentum in the x-axis. Okay, for a small unit mass, not unit mass, sorry, for a small mass dm, let's find the linear momentum, right? Linear momentum, the value of linear momentum is mv, right? And we will be applying that. So the value of v in the x direction is v cos theta, right? This thing right here is v, and in the x direction it will be v cos theta. Okay, and the unit mass, the not the unit mass, sorry, the small mass dm, this will have a mass of lambda r d theta. Okay, where lambda is the uh, mass per unit length of the train. Okay, which is basically equal to m by l. Okay, this quantity is equal to capital M by, and L is half the perimeter of the circle. Okay, now in order to find the entire the linear momentum of the entire system, we will just integrate this, integrate both sides, and dp will be from 0 to p. Okay, and cos theta, you can see this angle is theta, right? uh, this dark blue colored thing is theta, right? So at when dp is 0, that is for the extreme left point, this extreme left edge, the value of theta will be equal to 0, right? And at the extreme end it will be pi. At the extreme right end it will be pi. So yeah, let me just put all the values of say lambda and things like that over here. V cos theta, and in place of lambda, okay, lambda I'll put later, lambda r d theta. Okay, I'm sorry, the limits of integration won't be from 0 to pi. Okay, if we have this thing as sine phi, say v sine phi, it will be the same thing. Theta and phi are complementary angles, right? Let me just replace them with phi. And again, there won't be any change in d theta because d90 minus phi is also d phi only. So this thing is d phi. The limits of phi will be from 0 to pi. So as we know, velocity is constant, lambda is constant, r is constant. So we'll now integrate sine phi from 0 to 180 degrees. So the v lambda r, the integration of sine phi is minus cos phi, right? From 0 to pi. Now when we put these limits, we will find that the value of cos phi will be equal to minus 2, right? So it will basically be minus 2 v lambda r, and again there's a minus sign over here, so minus and minus will get cancelled. Okay, so this is the value of linear momentum in the x-axis, which will be equal to 2.54. This is the value of linear momentum in the x-axis. Now we have to find the linear momentum in the y-axis. But if you apply some common sense, you will realize that the linear momentum in y-axis will be 0. Why? Because say if the train is moving in this direction, then the linear momentum at this point will be in the downward direction as I showed, and at this point it will be at upward direction, right? It gets cancelled. Similarly, you will realize that in the y-axis everything gets cancelled. Okay, and so the dp, the y value of it, will always be 0. Okay, when we integrate it, the value will be 0. So this is the answer for you, 2.54. Thank you.